Good morning, everybody. Good morning. I am sorry I don't speak Chinese, only 2 words till now, but I will continue in English. If you have any questions or I'm going too fast, please hand up your hand, and I can explain again. I will talk about sustainable packaging and what is sustainability in packaging field. Packaging has a lot of roles, and I will start to explain some of those roles. One major role of packaging is protection, conservation. You see several examples, and maybe the nicest one is the yellow one, the banana. It's one of the best packaging ever found in the world. It keeps your banana completely fresh for many days. You don't need to pack it again. Another function of packaging is distribution, to keep things together. To keep things together. And you see some examples. On the low right, you see egg packaging, very important. Never seen in Europe, but I think this is an Indian picture. On the left, a bag just to take your packaging, your products home, necessary, otherwise you would have to walk many times to the shop. Another very important function of packaging is giving information to the public. Giving information to the one that buys the product inside. It's about marketing, but it's also about legislation, what should be on the packaging, warnings, or the preferable date of consumption, or the final date of selling. And more you see also the origin of the products. Which cow did produce the milk, which sheep did deliver the meat, because we want all to know where our food comes from. But above these essential functions of packaging, there are more ideas about packaging. It should be environmentally friendly. It should be reusable. We don't like all the plastics and to have a lot of waste after we bought a product. And in fact, we don't like to see the packaging back in nature afterwards, in the river as litter, or finally in the ocean, the plastic soup issue. Tons of plastic being down in the oceans for many years now, and finally found back in our food, in fish that we eat. And one other is, packaging should not distract from the product. It should be a nice present instead of an ugly box around it or an ugly plastic something where you want to eat something nice. But coming back to environmentally friendly, it's a difficult question. What is environmentally friendly? It's also protecting, because if we waste a lot of food because food isn't packed properly and we have to destroy the food before having had time to consume it, it's a lot of waste. It's also about food safety, like the former speech. If bacteria comes in and we get sick, we'd better pack it more and prevent it from being infected by bacteria. It's also about, what I said, look and feel, and about waste reduction and waste separation. So, what is environmentally friendly is a complex question. And I will go into that in more detail now. One major aspect, and also mentioned before, is it bio-based or fossil-based, oil-based? And bio-based is defined in different norms, standards all over the world. One of the most known is the ASTM6866 standard. It's about all sorry, all materials coming from recent biomass and not from ancient biomass like coal and oil. And it can be directly used out of the wood or plants or starch or proteins, or it can be indirectly coming from fermentation, for example, like algae. Examples of how we how in the world organizations tend to favorite bio-based. One of the examples is the USDA, the American preferred program for bio-based products. And the government only wants to buy the most bio-based products instead of fossil-based products. Another criterion, like bio-based, is it biodegradable? It's quite different. One is the origin is coming from plants and not from oil. The other one is it biodegradable? And that means it can be degraded into the biosphere again. But note, it's important to note, not all bio-based products coming from plants are biodegradable. And also vice versa, there are biodegradable products coming from oil. So also there, it's always a difficult discussion, what is the best to choose? And of course, it depends on many more factors. Let me go into biodegradability first. That's about compostability, also defined in several worldwide norms. And one of the most known is ASTM 6400, as well as the European norm 13432. And it defines compostability as it must be degrade into carbon dioxide and water and minerals. So reusable for plants. But another aspect is also it should not stay as large particles, but it should disintegrate into small particles. It shouldn't have contain heavy metals, and it shouldn't be toxic for the eco-environment. So plants should be able to grow in it. And you know, I think perfectly, there are several certifications available from the Geerts, from Winschotte and other certifications institutes. And it's worth to note that. And also there is a big difference between compostability in an industrial way at higher temperatures or compostability at home on normal temperatures, outside temperatures. As I said, environmentally friendly is a difficult issue. I think the most favorable way to approach it is to do a life cycle analysis and to, as I the light is not on. On the right, on the right you see the life cycle of products starting in the wood, the raw materials, in this case fibers, but can also be plants, and going to the processing, making wood out of it or making products out of it, into the manufacturing of, in this case, packaging, to the use phase. We buy a product, we use the product, we throw away the packaging until the end of life cycle, where we either reuse the product or burn it or use parts of it again. And it's in a life cycle approach, from every step, it can be calculated what are the effects to the environment. And one of the most important ones at the moment is the global heating, global warming, and that's affected by carbon emission equivalents. So one of the measures for a life cycle analysis is to measure in all steps what are the carbon dioxide emissions. And you can do that for packaging as well. And I will come back on that later. But even there, it's worth to look at the system variables, the system boundaries. If you have not a good packaging and you lose a lot of food, it's a lot of waste generated by the packaging, so you should calculate that food waste as well. And it could be concluded that a better packaging with more volume, for example, more weight for the packaging, isn't totally better because you have less weight if you pack the food better. There are already several types of bio-based packaging available. And if you look to the list, and it's not endless, a wooden crate is a perfect bio-based packaging coming out of the forest. It's mostly reusable, or it can be burned in the end, generating energy. Carton is the same. It's a product out of fibers from wood, and it can be reprocessed many times to make new corrugated, and finally it can be converted to biogas, for example. Cellophane or paper, same types of bio-based products already existing for many decades or even longer. On the right, I put some of the aspects you could take into account into a life cycle analysis. And of course it depends in all steps about your own criteria, but with the pluses and the minuses, I have indicated some of the aspects, evaluated them. There are also, at present, the last decade, many bioplastics available. And bioplastics mainly generated from sugar type or starch-based products, and they result in, for example, a biopolyethylene or a bio-PET. They come not from oil, so they are bio-based. But in some cases they are biodegradable, in other cases they are not biodegradable. Bio-PE is not biodegradable, but it's bio-based. It's not using oil, and as such the carbon emission, for example, for bio-PE is lower than for non-bio fossil-based polyethylene. And again, I listed some of the aspects and evaluated them. And you see, for many plastics, the product protection is much better than for wood or paper, because bacteria can't enter easily. Humidity is conserved better. But there are plastics and non-compostable in general. So on the lower side, you see many minuses. They are contributing to the plastic soup. They are contributing to litter, but they are bio-based. Then there is a class of what we call now new materials, and I hope in a couple of years we call it existing materials. Like PLA. PLA is coming from sugar, from starch, and you see it in many cases around bananas, at least in Europe and the US. It's a bio-based packaging. It's compostable, although not home compostable. You need higher temperatures to compost it. You also see PHE, And you see many new experiments with using the rest of plants that we eat. For example, tomatoes. In the Netherlands, we have seen experiments with boxes made out of tomato leaves, or boxes made out of aubergine leaves, etc. Many types of waste that is normally burned or fed back to the soil are now used first for packaging issues. They are still on a high price level because experimental, but it are nice marketing experiments as well, because if you buy a kilogram of tomatoes and the producer says, well, the packaging is also made out of tomatoes, it's a nice story. And also for the environment, a better step than have a plastic bag around it. In the same type, you see pulp made out of partly fibers from grass. There's a lot of grass available. When it's mowed, you can enter that into the pulp mass and you can make boxes out of it, which saves trees. It's a 1-year herb instead of a 20-year tree. And on the bottom side, you see PaperFoam. That's a product our company develops and produces. I will come into that later. On the right side, you see more pluses at the moment, because in this evaluation, you don't see any litter, because all the products are biodegradable. It's not plastic, it's not oil-based, it's bio-based. But on the food safety side, you see also minuses, because the materials are not that conserving for food as plastics are. Not at the moment, at least. Then I come to PaperFoam. I show you some products. And outside the hall in the coffee room, there are more. PaperFoam is a product made out of starch, and I used to know the word in Chinese, but I forgot it. Can anyone translate starch? Starch. Starch. Starch in Chinese. Tian of Tian. Tian? Tian first. Okay. It's a lightweight product made out of starch and fibers. It's made via injection molding. So like plastic injection molding, but a little bit different. And it results in a very low carbon footprint product, both because we don't use much water compared to paper. Paper is made out of waste paper and fibers and uses a lot of water, resulting from, let's say, 2 or 3% dry matter batter. PaperFoam is made out of a 50% dry matter batter, from starch, from fibers, from water, and a premix to steer the properties. And that water has to be evaporated later, like in paper, like in pulp. That uses energy that results in a carbon dioxide emission, but as I said, much less than for comparable packaging. And we use the packaging for electronic, for cosmetics, for medical devices, and for food applications. Can you help me? But I don't know what is. Okay, thank you, thank you. In this table, I put several materials on the left, and you see in the second column the carbon emission per kilogram of product. And you see on the low end, it's only 0.14 kilogram of carbon dioxide per kilogram product. Compared to the others, it's much less than that. The density of the product is almost the lightest, but EPS, polystyrene, expanded polystyrene, is much lighter, 0.03 versus 0.18. But if you have felt the product, you may see it's very light. I'd like to show you some examples of different types of packaging. And in the table I compared all the packaging with their previous packaging in other material. On the second column you see originally a packaging for a modem for TV connection. It used to be in a bagasse pulp, 87 gram. We converted it to PaperFoam with the same weight in this case, 87 gram. But the carbon dioxide emission for, in this case, 100,000 units dropped down from 18 ton to 1.2 ton of carbon dioxide. And that's a huge difference. If you convert that to use the same amount of carbon dioxide that you saved by converting to this packaging. The bottle packaging, it's going around now. It's champagne packaging for Vijf Clicquot. They wanted a packaging that is insulating the bottle. So if you drive to your friends for, say, 2 hours, you can hand them over a cool bottle of champagne. And there the packaging came from a neoprene packaging, a plastic packaging, weighing 175 gram, no, 100 grams. And we went to a PaperFoam packaging of 75 gram. And there we dropped down from 36 tons of carbon dioxide to little more than 1 ton carbon dioxide. Again, for 100,000 parts. Well then, the egg packaging above, a Dutch brand, giving 7 eggs, every day an egg, dropped from pulp, 30 grams to 25 grams, and from 5 tons of carbon dioxide to 0.34 tons of carbon dioxide. And on the most right column, packaging for electronic devices, dropping down from EVA foam, 275 gram, down to 112 gram in PaperFoam, and resulting in a gain of, well, more than 35 ton of carbon dioxide. And again, 370,000 kilometers in a normal Volkswagen Golf standard carbon dioxide emission gained. To end, I want to show you one more example about egg packaging. And I think we have the most environmentally friendly egg packaging, but also the most eye-catching egg packaging compared to all the gray pulp packaging available or the same type of plastic packaging. And if you look at this column, I put on the left the PaperFoam Red Fog egg packaging, then a PET egg packaging, mainly found in the US and some European countries. In blue, a polystyrene packaging. And on the right, the very common pulp packaging, in black in this case. In the red dots, you see the weight of the packaging. So the pulp packaging was 42 gram. The PaperFoam packaging is 30 gram. The lightest is the polystyrene, expanded polystyrene packaging, 12 gram. But in the columns, you see the carbon dioxide emission dropping down almost 90% from pulp to the PaperFoam packaging on the left. And if you would calculate what that means for China, I did a rough calculation. If every one of you would change every week one packaging for a PaperFoam packaging, that would result in about 65 billion packages per year, but a saving of 6 megaton carbon dioxide equivalents per year. And 6 megaton is about 1%, almost 1% of your total carbon emission for complete China. So I think that is a nice step to take. So I want to see fingers whether you think you can buy a packaging next week, and the week after, and the week after. Who does? And that's my end of the presentation. Thanks for the attention. If there are questions, please ask me.
So, questions? Please save me some time. I also have a question to ask, okay?
我想咨询一个问题啊，刚才讲到那个发泡。
So you talked about the advantages of a paper foam. So how about the mechanic properties? He was test. Can you hear me? Yeah, he was saying compared to the traditional material, you mentioned that the paper foam is light and has less CO2 emission. How about its mechanical property like strength and also other properties? Does it also have advantage, mechanic properties?
Okay. I will repeat the question in English for those who understand English. The question was, I told about the lightweight and the compostability aspects of PaperFoam and the low carbon footprint. But was the question, how about other properties of the material, like mechanical properties, strengths, etc.? Well, PaperFoam is suitable for packaging of, say, maximum 1 kilogram. We are conforming ISTA test, drop test, for example, up to 1 kilogram. We can use both design and recipes to that. So the strength is comparable to pulp and paper, carton, but it always depends on the right design and the product. But many products have been approved for packaging for mostly cosmetics, medical devices, electronics, say up to 1 kilogram. Is that an answer?
Good morning, Mark.
Hi.
Thank you very much for your presentation. So I have 2 questions. So the first one, I think, for this kind of paper foam, and I think, can this material directly contact with food, like chocolate, cake, or chips? This is the first one.
Yeah, PaperFoam is suitable for dry food packaging.
So you have the QS certificate in China?
Not for China, we have it for Europe. But I think it's comparable for the Chinese regulation, so it would be possible to reach that certificate as well.
Okay, thank you. So the second one is, I think, versus like a PET trays or PET containers. So does this material have some cost advantages?
Well, on the cost level, it depends very much. I'll give you one example. We are packing a lot of shavers and toothbrushes for Philips. We produce them in our plant in Malaysia, our plant in the US, our plant in Europe, and probably soon also in our plant in Shanghai that just opens. The packaging there is compared to pulp packaging. They used to use pulp, but when packing, for example, a shaver in pulp, you need a polybag around it because the pulp is scratching the device. PaperFoam is soft, as you have felt, so you don't need a polybag. If you compare a PaperFoam box with a pulp box, the box for PaperFoam is more expensive. But if you compare the total packaging process, the handling as well, then PaperFoam is cheaper.
So maybe in the other way, I want to ask, like for the egg case, right? You launched in Europe or USA. So for the egg case versus normal PET and PaperFoam, which one is relatively cheaper or similar?
Well, the pulp in Europe is cheaper. It has a reach from, say, 8 cents, euro cents, till I think 20 cents. And our range is about from 15 cents till 22 cents.
Okay, got it. Thank you.
Yeah? Okay, thank you.
Okay, I think the time is